Hello and welcome to the Kubernetes podcast from Google. I'm your host, Caslin Fields.
And I'm Mofi Raman.
At Google Cloud Next, Abdel sat down with Nick Eberts, a product manager at Google, and Jon Lee, a software engineer at Google, to talk about Multi Cluster Orchestrator, or MCO, a new open source tool announced at KubeCon EU 2025. MCO addresses the need for managing workloads across multiple Kubernetes clusters, especially with expensive accelerated hardware like GPUs, which require efficient scaling. But first, let's get to the news.
HCD has released version 3.6.0. This is the first minor version release in about 4 years since June 2021. The new release includes some exciting updates like downgrade support and some significant performance improvements. Check out the blog on hcd.io for more details.
Kubernetes 1.33 is now available in the Rapid channel on GKE. This update comes just 2 weeks after the open source 1.33 release.
Kyverno 1.14.0 was released, marking a significant milestone in the journey to making policy management in Kubernetes more modular, streamlined, and powerful. This release introduces 2 new policy types, validating policy and image validating policy. Kyverno 1.14.0 begins a new chapter for Kyverno with the introduction of specialized policy types that separate concerns and confusion about validation checks being written in various patterns by providing a more focused approach to functionality.
And that's the news.
Hello, everyone, and welcome to a new episode of the Kubernetes podcast. I'm your host, Abdel, and we're here live from Google Cloud Next 2025. I am here with Jon and Nick. Hi, guys.
Howdy.
We're going to be talking multi-cluster orchestrator, which is something we actually announced at KubeCon London last week. I don't know when this episode is going to be out, but last week, whatever that last week is. But before we get there, let's start with some introductions. Why don't we start with you, Nick? Who are you? What do you do?
My name is Nick Eberts. I am a product manager at Google working on GKE and all of the multi-cluster tooling that we build, mainly fleets and, of course, multi-cluster orchestrator.
Awesome. And Jon?
Yeah, I'm Jon. I'm a software engineer, also working at GKE, closely with Nick. In the past year or so, I've been focusing on inference on a lot of the Gen AI workloads.
Like everybody, basically, these days. Awesome. So let's start with something basic. Multi-cluster orchestrator. We announced that last week. There is a blog out. There is a GitHub repo somewhere. Why don't you explain to us what is MCO?
Yeah, sure. Actually, before we explain what MCO is, I'm going to have Jon describe the problem. So Jon and I, we got together about a year ago to try and solve this particular problem. I'm going to let you go through and describe.
Yeah, let's start with that.
Yeah. In the past 2-3 years, we see the cloud to evolve. When we first built Kubernetes, it was built with the assumption of the cloud is infinite and the cloud is uniform. You have infinite amount of capacity. CPUs, they're all about the same everywhere. That's the assumption we took back 10 years ago.
Yep.
Kubernetes was started. When accelerators started to enter the picture, right? It's not quite infinite. We got stockouts. Sometimes our customers can get capacity. Also, is also not uniform, right? The different generations of GPUs and TPUs, right? That calls for a different solution, right? Like when customers have stock out in one region, right, it's natural to expand out to different regions close by.
Sure.
And also for a lot of the inference workloads, your latency requirement is not that strict. Actually, going a little bit further is okay. So that kind of calls for a multi-region, multi-cluster solution.
Got it. And before we start talking about MCO, Nick, I guess that this problem of managing multiple clusters is not even new to the inference world. Like it have existed for a while. And it has to do with things like, I need to run my app closer to where my customers are. That would be one of them. So it's not only just like stockouts and running out of availability of hardware. But I want you, Nick, to try to answer this question. Where are we right now? Where do you think we are on the question of one large cluster or multiple small clusters? Because that kind of blends into this conversation, right?
Yeah, at Google or even upstream Kubernetes, we're making pretty massive clusters these days. We have 65K nodes. I know you did a podcast about all that.
Yeah.
But it's not just because you can, I think, doesn't mean you necessarily should.
Got it.
Even though your cluster can be massive, there's still like the blast radius of the control plane on any particular cluster.
Sure.
And the idea here is you don't want like too many small clusters, and I don't think you necessarily want one massive cluster, but you certainly want some kind of middle ground in between, in which maybe you have a cluster that represents a shape of applications that bin pack nicely together to a region. And so the idea is that the goal of the products that I build and what I'm trying to push upstream is this ability to think about how you want to bin pack applications together onto the same shapes of clusters. Clusters are fungible, and not really have to think too much actually about a physical cluster. Here's this set of configuration that represents these apps.
Got it.
And I want to make sure that it runs highly available, and I have customers in maybe these 3 regions, and just make sure that it's there for them to make answer lower latency requests.
Got it. Got it. And we're going to talk a little bit about details of how MCO works, because I had to go do some reading to prepare for this episode. But then let's get into it. What is MCO?
Yeah. I'm going to take a second here just to describe what we have without MCOs.
Sure.
To maybe lead into what MCO provides. So if you're going to build a multi-cluster inferencing engine,
sure,
like you could just build that. Literally, you could deploy n number of clusters across n number of regions. You can host that inferencing app in those regions. And by the way, inferencing is just the serving app.
I know that there are some nuances there.
As it relates to networking and workload placement, I think that you could think of them somewhat the same. But the point is that you can have these clusters set up across multiple regions. Then you just need to make sure you have a load balancer,
sure,
that can reach them. And you want to make sure that load balancer can route traffic based on preferences, right? So you can ensure that if you want most of your requests to go to a certain region, there's like a preference so it can send traffic there. So you could do all this in Kubernetes. There's lots of ways to solve it today. But the thing that you can't really solve for unless you introduce like a PaaS service running in Knative or any of these services that can scale to 0 in a cluster, what you can't do is take those workloads, those inferencing engines running in all those clusters and scale them to 0.
Sure.
Now, this is one of the main differences when you're talking about accelerated hardware versus regular CPUs. Accelerated hardware is expensive. So like you don't necessarily want to have to pay for GPUs in regions where they're not serving requests. So just having to have a GPU sit in a region just in case is not really cost effective.
Yeah.
Right. And so the general problem that one of the problems that we're out to solve with Multi Cluster Orchestrator is this idea of taking secondary regions, taking the HPA of those workloads from 0 to 1, right? When there's a need for them to scale out, and then also taking them back to 0 when there's no longer a need to have that inferencing engine running in that extra region.
Got it.
So Multi-Cluster Orchestrator's job is to allow an ML operator or just a workload operator to define a set of priorities. And those priorities are like which regions they prefer, which clusters they prefer, stuff like that. And then evaluate those against actual capacity and return a result that's a recommendation for which particular cluster in your fleet should this workload land. Now, I just want to be clear, it's just making a recommendation.
Yeah.
So what Multi-Cluster Orchestrator is not is a CD tool.
Yeah.
We have enough of those. I don't think we need more. And so like the first implementation that you'll see is with Argo CD, because that's where most of our customers are right now, but we are working upstream to get it to work with Flux and also config sync down the line.
And so the work you're doing upstream is to standardize the way those like recommendations are spit out by MCO so they can be consumed by like a CD tool?
Yeah, so MCO is open source, and we believe it's still early days, but the idea is that we're going to have almost like a cloud provider model. Well, not a cloud, I shouldn't say cloud provider, but a provider model. So if you're a Kubernetes provider in which you could plug in maybe an API that MCO is going to call to search for capacity.
Got it.
And also we are going to make the metric that determines whether or not there actually is a capacity issue in any region that's live, open and accessible, so that you could bring your own sort of metric to evaluate the running workloads and decide whether or not they're stocked out, or any logic that you want to decide to add another cluster or remove cluster. So those are the two, that's like the surface area for integration with other providers. Yeah.
Got it. Got it. And Jon, you were going to say something about inference specifically. I want to hear your thoughts.
Great, yeah. For inference, like earlier I said, it's just like web service. In a lot of sense, it is stateless, not keeping track of any states. It's not typically connected to any like relational database. In those sense, yes, it's very much like a web server. There are also cases where it's not quite like a web server, where oftentimes it's the actual computation is done by an accelerator. And with transformer inference, it is auto-regressive. And the workload is divided between prefill and decode. Prefill typically is very compute bound, and decode is memory bandwidth bound. And auto-regressive in the sense that, for one pass forward of the neural net, you generate one token.
Yeah.
And then you keep generating until you hit the end of sentence token. So because of that nature, the latency here could be in the order of seconds, as opposed to what we're used to in the microservice world, like things are in the millisecond realm. So that's the major difference.
Yeah, so to rephrase what you said, basically traffic for LLMs is not your typical web traffic in the sense that the request could be long, the size of the request could be big, and there is also the fact that a lot of these LLMs today are multimodal, so the request is not always text. It could be like audio, it could be video, it could be a picture, it could be whatever, both the request and the response.
Yeah.
And I think that's partially what the Gateway API inference extension is trying to address.
Yeah.
And we're going to have an episode about that, but I want to go back to MCO. I was looking at the demo that you built, Nick. So there is MCO, and there is this thing called workload placement, which is a CRD object, right?
Yep.
You deploy that, you say, I want this workload. These are my list of clusters in order of preference. And then it spits out in its status field a recommendation.
Correct.
And then you plug a CD tool to take that recommendation and do something with it, right?
Yeah.
But MCO itself builds on top of two things, the cluster inventory API and the cluster profile API.
Correct.
So what are those?
Yeah, so actually, just to be super clear, cluster inventory isn't an API as much as it's just a word to describe a number of cluster profiles.
Okay.
So cluster profile is a CRD that we built upstream in SIG multi-cluster, and it's essentially just a pointer to an actual cluster. But the idea the thing that we notice is that like a lot of providers were building their own cluster lists, including us. We have fleets.
Yeah.
Azure has fleets, like OpenShift has their own version of things. And then a lot of like multi-cluster tools for maintaining their own lists. If you use Argo CD, the secrets on your central Argo CD server are essentially a list, right? If you're looking at multi-queue, that's another service. It's a multi-cluster type of workload distributor, right? That thing has its own list. And Multi Cluster Orchestrator could have had its own list. But what we tried to do is normalize that list into those open source specs. Essentially, if you think about it, all of the clusters that are generated as cluster profiles in a namespace on a central hub cluster, and that's actually a term that we've decided to accept upstream, it's the hub cluster. Those represent like a sameness boundary to some degree, and you could consider them to be analogous to a fleet.
Got it.
And that's what in cluster inventory is. It's a number of cluster profiles.
Got it.
And so, and it's not just like the cluster name, it's all the metadata that you want to decorate that cluster with.
It's almost like the capability list, right?
Yeah.
For cluster, it's got GPUs in it. Like also that cluster is got certain networking. It's a way for you to express what this cluster can do.
Yeah, the word cluster inventory is pretty self-explanatory,
Sure,
in my opinion, but it's still interesting to talk about it. So I think my follow-up question then would be, who generates, by who, I don't mean the person, which part of a system generates the cluster profiles? Is it something that you would generate as a user manually, or would you write like something to generate it? So it would query your cluster and then generate the profile and update it?
Yeah, I think the whole point of cluster profile, is to remove the need from an end user to have to write a bunch of glue code to sync all of these disparate lists together. So if you add a cluster before a cluster profile, you'd have to add that cluster, you'd have to add the Argo CD secret, you would have to add n number of other entries to a list somewhere that represents that cluster. So I think what I'm seeing is, both with Microsoft certainly and us at Google, is we have a service that's generating the cluster profiles based on the cluster create. So like, for example, if you're using GKE fleets, when you add a new cluster to the fleet, we are automatically going to create a cluster profile on your hub cluster that you've identified with a label and say, so we are going to, everything gets added. Every time you make a change to some metadata on a label, we're going to reflect that into the profile.
Got it.
Yeah.
And that's what MCO uses as an input to say, these are my available clusters. And for each cluster, these are the capabilities, as you said, John.
Yeah, that is let's say that's, if in terms of SQL, that's the select, right?
Yeah.
And then there's a filter that you can apply to it, which is part of the spec of multi-cluster Orchestra in that placement.
Yes.
So you could do regex, or you can hard code the list, and then shortly we're going to provide a way for you to use label selection to decide which clusters, because not every workload in your fleet probably needs to be a target not every cluster in your fleet probably needs to be a target for MCO.
Yeah, sure. You don't have to add all the clusters under MCO, essentially.
Yeah.
But so then a follow-up question would be, the engineer in me is thinking one problem that could happen is if your cluster profile is not up to date, would there be a situation in which MCO would make a recommendation that would be outdated in a way? Especially think about it as you have multiple clusters and then multiple people are using other tools to deploy these clusters. So how fast can you reflect the status of a cluster to MCO matters in this case?
Sure. I can only speak for how fast we could do it in GKE, and it's
Sure.
on the order of milliseconds. It's pretty quick.
Okay.
But that's up to, I think that's an implementation detail of the provider of cluster profile. That's not even an MCO thing. That's just like how quickly is your sync occurring between whatever that source of your cluster list is and the actual hub cluster with the profile.
Got it. Got it. Okay, cool. And so MCO is under SIG multi-cluster, right?
Not yet.
Not yet. Okay.
That's the intent.
That's what you're trying to do.
Yeah.
All right. And when do you expect people will be able to like play around with this?
Yeah. So depending on the time of release, maybe today, but so 2 weeks after next, let's say, is our goal. And so the first thing you're going to see is that the images, so it's going to be first available, obviously, for GKE clusters because this is the team that's building it. And so the images for the binaries will be public and available in the GitHub repo. And then you'll have a Terraform sample that shows you how to build it all out using our implementation.
Got it.
And then shortly after that, we're actually going to release the code into that very same repo. And then over the next 6 months, I'm going to go through the process of working with SIG multi-cluster to figure out how, where, and when it gets pushed in.
Got it.
Yeah.
And another question to you, John, on the inference side, because the demo that I saw that you built, the one that is internal for now, does also leverages multi-cluster gateway for multi-cluster load balancing for inference. Is it based on the GKE inference gateway or just the regular gateway?
So that's based on a gateway class that we built for GCP. That's a multi-cluster, multi-region internal load balancer gateway class.
Got it.
There's also some other work that we're doing upstream with the gateway spec in respects to inference pools.
There's a separate inference gateway.
Yeah, so that's what that was actually my actual question. And my follow-up would be, because I did some reading about the inference extension and I did actually talk at KubeCon last week, like a lightning talk about it. And part of what this does, there is this thing called the endpoint picker, which kind of plugs the inference pools into the gateway itself to tell the gateway where to route traffic.
Exactly. Yes.
So how do you see this plug into MCO? Is this something, is the inference extension going to be able to leverage MCO in a way?
Yes. So that's something we're still actively figuring out the details, but I can give you some high levels.
Yeah.
So MCO, what you think of, like the routing at that layer, right, is region picking.
Yes.
And then what EPP does is the endpoint picking.
Yes.
Right? So you can think of this in 2 layers, right? So first, when the request goes in on the data path, right, you first decide what region you assign to. And then once you get to the regional level, like what EPP is going to give you is it has the capability, instead of doing round robin load balancing, it can use a custom metric, for instance, KV cache utilization, to fully balance all your accelerators.
Or queue size or something like that, yeah.
So the latency that it works at is in the milliseconds. Like it needs to be fast because it needs to be able to route to an endpoint. That's the latency we're working with. And for regional picking, what we wanted to do is we wanted to send to regions where there's capacity.
Yeah.
And the latency there doesn't actually need to be that low compared to the endpoint picking part.
Of course.
So think of this as a 2-layer.
2-layer problem, yeah.
So first, pick the region, and then we have ways to direct shape traffic to regions where there is capacity. And second, once a whole bunch of requests lands there, there's mechanisms to balance the load among all the accelerators as doing the endpoint picking.
I think my question was kind of slightly more broader than that, in the sense that if you have a situation where you need to auto-scale based on utilization, right, that MCO would be able to be plugged to make that workload placement auto-scale and recommendation, or am I?
So MCO's job is to take it from 0 to 1 and 1 to 0.
Okay.
The HPA takes over once it gets to 1.
Got it.
So you're going to configure the HPA on a metric that makes sense for that particular workload. In the case of inferencing, we've seen people use KV. We're recommending like KV cache or maybe even Q depth of the LLM.
Or maybe metrics from the GPUs or something. Yeah. Cool. Awesome.
One thing we'll add though, like on the multi-cluster gateway side, right? This is, I guess we're getting more to the details of GCP. There's something called preferred backend.
Yep.
That is for the customers to say, I wanted to shave my traffic to a particular region. right? For reasons like if people have bought reservation in that region, they want to fill it up, right? So those are ways to steer traffic and shape traffic. And then once you've done that, MCO can auto-scale that workload to that region, and also HPA can scale the number of nodes
within the region.
Pods and then nodes.
Awesome. Thank you very much, folks. This was pretty cool. I'm looking forward for MCO to come out, and maybe one of you coming back on the podcast to tell us more about the new stuff.
My goal is to have this conversation with you again in 6 to 7 months and talk about its sort of birth into SIG multi-cluster and use by other companies besides Google. That's 100%.
Awesome. Last time we had you on the show, that episode was very popular, so we're happy to have you back.
Right.
And then maybe we can have John come back to talk about Szechuan peppers, because I've heard you guys gossip a bit about Szechuan peppers.
We could do a whole episode on cooking.
Right. Well, probably not on the Kubernetes podcast, but...
All right.
Awesome. Thank you very much, folks.
All right. Thanks.
Thank you.
That brings us to the end of another episode. If you enjoyed the show, please help us spread the word and tell a friend. If you have any feedback for us, you can find us on social media at KubernetesPod or reach us by email at kubernetespodcast@google.com. You can also check out the website at kubernetespodcast.com, where you'll find transcripts, show notes, and links to subscribe. Please consider rating us in your podcast player so we can help more people find and enjoy the show. Thanks for listening, and we'll see you next time.